Hello and welcome to Podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app or want to try a project you hear about on the show, you'll need somewhere to deploy it, so take a look at our friends over at Linode. With the launch of their managed Kubernetes platform, it's easy to get started with the next generation of deployment and scaling, powered by the battle-tested Linode platform, including simple pricing, node balancers, 40 gigabit networking, dedicated CPU and GPU instances, and worldwide data centers. Go to pythonpodcast.com/linode, that's Linode, today and get a $100 credit to try out a Kubernetes cluster of your own. And don't forget to thank them for their continued support of this show. Your host, as usual, is Tobias Macy, and today I'm interviewing Smit, Shah and Sayan Chakraborty about Luminaire, a machine learning-based package for anomaly detection on time series data. So, Smit, can you start by introducing yourself?
Hi, my name is Smit Shah, and I'm working as a senior data engineer at Zillow for almost 4 years. And I'm mostly involved building data-related products at Zillow.
And Sayan, how about you?
Hi, my name is Sayan Chakraborty. I work as senior applied scientist in the Zillow AI team. I mostly work on anomaly detection and help building the anomaly detection and in turn the machine learning methods inside Luminaire.
And going back to you, Smit, do you remember how you first got introduced to Python?
Actually, when I joined Zillow in 2016, that was the very first time I got into Python, as most of the data teams were using Python. So I started learning more about Python and using it. And it's really easy and convenient language to use, and I really love it. Just before Python, I was more into Java and Objective-C programming.
And Sayan, do you remember how you first got introduced to Python?
Yeah, so I'm from a stats background. So I used to code in R. And I remember during my third year of my PhD program, I decided to learn a new language and Python was picking up and I thought it would be a good candidate. I'm full on Python. I think I didn't wrote any code in R in the last 2 years.
Yeah, that's definitely one of the interesting sort of ongoing holy wars in tech is Python versus R when it comes to stats. So I'll leave that at the sidelines for now, but I think it's funny that you started in R and have since come over to Python. And so I'm wondering if you can just start by giving a bit of an overview about what the Luminaire project is and some of the origin story of how it got started and why you decided that you needed to build out this library from scratch.
So Luminaire is a tool for detecting anomalies, specifically for time series data. And we do it for both batch and streaming use cases. In the place where Luminaire stands out is automating the whole modeling process and somehow democratizing the anomaly detection across the community, because anomaly detection is a hard problem and not everyone comes with the domain expertise or the ML expertise needed for doing anomaly detection. That's where Luminaire comes in to automate the process.
And what's the story behind the name?
So the dictionary definition of Luminaire is complete electric unit of light. And one of our Zillow's core value is turn on the lights. So as Sayan mentioned, we wanted to democratize anomaly detection. And we also wanted to bring visibility to the teams about various anomalies or data health issues in their data. And that's how we came up with the word Luminaire.
And so there are a number of other projects that are intended for working with time series data, even just within the Python ecosystem, one of the most notable ones recently being Prophet. But I'm wondering if you can just give a bit of an overview about where Luminaire fits within that ecosystem of time series frameworks and libraries, and what are the use cases that it's well suited for versus when you might want to use something else.
Luminaire is built for anomaly detection. So it's focused on classifying anomalies. So when you are talking about other forecasting packages, those kind of depend on how much signal that you're getting from the data. But anomalies are anomalies. So they can show up either you have signal in the data or you don't have any good signal in the data. So that's where Luminaire come in. We have built the library in such a way it's focused on detecting anomalies for time series data and brings automation for when the user wants automation. And whoever wants to play with the model, we also open up the configuration for doing all the changes during the modeling. So it's kind of also works well in terms of building an explainable model for anomaly detection. And specifically, like for forecasting, we actually have seen like whenever you have good signal, Luminaire can be used well as a forecasting tool, and it performs pretty well whenever you have good signal in the time series data. We actually recently submitted a paper in IEEE Big Data Conference this year, which got accepted, and we shown like some few benchmarks where we have shown like Luminaire is outperforming many other competing forecasting or anomaly detection methods in different scenarios. That ranges from like Luminol, ADTK, even AutoArima, and also Profit as well.
Because of the fact that there are so many other libraries out there for time series, what was the motivation for actually starting an entirely new project versus just adding new capabilities onto an existing library, or just wrapping it and adding some specific functionality to it?
Basically, like we wanted to have solving the anomaly problem in both worlds. Like either we wanted to have more control over the model building process, or we wanted to build an anomaly detection tool for those users who wants more automation. And Luminaire comes good in both world. And we have seen like in many others. So when we were building this anomaly detection tool, we looked for several existing solution, and we found like there is no such tool that is solving this problem in a robust and reliable way, because I mentioned before, like most of the tools which are more sophisticated for dealing with time series data are focused on forecasting, not for anomaly detection. And those tools which are focused on anomaly detection does very basic modeling, has very basic modeling capabilities. So that is where Luminaire comes in, which is kind of combining these two capabilities into like a more powerful, more sophisticated anomaly detection platform.
Yeah, let me explain like how this whole Luminaire project actually got started from inception. So at Zillow, since we are a data company and the company identified there was a need for having a centralized data quality team, and that's where our core team got formed. And what we observed also was there was no standard or formal processes that everyone were following in general to detect their general data health issues for their metrics. And that's where we started creating standards and processes to help these teams out. So that's where the very first utility function in Python was created internally, which was helping teams to generate data health metrics like volume, availability, completeness, or even comparison. And later on, teams were interested to have not getting alerts on top of this matrix. So we started building deterministic anomaly alerts on top of this. But later on, we also found that we had a lot of time series use cases within a lot of our teams. And that's where the need for doing a time series anomaly detection came in. And that was the first place where we built this, where we added this utility function within our core package to detect time series anomalies. And we started with the off-the-shelf ARIMA model. But from that point and onwards, we then saw like, okay, these are like two different use cases. And that's where we splitted the project into like Luminaire deterministic checks and this Luminaire, what we have open sourced right now, which is the core time series anomaly detection. And from there and onwards, we started adding more models, more sophisticated models to support just time series anomaly detection, and overall trying to democratize self-serving anomaly detection at scale. And over this period, like our core team, which I would like to also mention, just not just two of us, but it was also like Anna Swigot, she is our dev manager, and then Luya Yang, Kumar Soltani, and Carl Buckingham, who were there from the initial days of building these packages. So I'd like to also thank them.
And in terms of the ways that it's being used now, you mentioned the data quality aspects of maintaining your data pipeline. And Sayan, you also mentioned actually using it for some of the forecasting capabilities. I'm wondering if you can just discuss some of the different ways that it has grown to be used throughout Zillow within the data team, but also maybe some use cases outside of just the specific data pipeline and data analysis lifecycle.
Yeah, sure. So within Zillow, like we currently don't use it as a forecasting tool, but use it as an anomaly detection platform. So in general, like we have lots of like internal and external services, and we process enormous amount of data every day. So there are data producer who generate like batch or streaming data that gets consumed by the different downstream services, and the producers wants to make sure the data they are generating are good quality data, as well like the downstream team who are consuming this data and creating maybe business matrix or generating feature for their ML system, like for example, like Zestimate, Zillow offers, the recommender system we have in Zillow. All of their team, they want to make sure like the data they are ingesting is good enough. So that's where Luminaire comes in. So Luminaire intervenes different part of this process pipeline and makes sure the data flow and the data that is going from one place to another is good quality and does not have anomalies. So we do different checks, so like checks for volumes, like availability, nulls, completeness, and so on and so forth, and to make sure the data within Zillow and that's being ingested to the services are healthy enough.
Just wanted to say, like, sometimes also, so that's where we were saying, like, we were trying to bring this standard or processes at Zillow and trying to guide them, like, what data health means, what quality means. So that's where we started teams to encourage more on not just working on building the data pipelines, it's not their end goal, but it is also making sure within your pipeline process, you are outputting healthy data. And that's where, as Sayan mentioned, like we act as an intermediate intervene process where team leverages this tool.
Particularly for things like data quality, or if you're in the operational use case and you're doing anomaly detection on maybe system metrics, it can be very easy to accidentally get to the point where you're generating too much noise because there's a certain variance in the signal, and so it can be hard to determine if something is meaningful or not. And I'm wondering if you can maybe dig into some of the complexities that are inherent to anomaly detection that are not obvious at first glance and that are difficult to overcome, or that are important for avoiding the case of creating too much noise that people will start to ignore the types of anomalies that are being detected.
Anomaly detection is a challenging problem indeed. Specifically, like if you are building an anomaly detection model for a given problem, like a given data set, you can keep on optimizing that because you can ingest more data, more information about the data, and you can keep on optimizing your model so that it works best for that data set. But from a tool or from a service perspective, when you're making like an anomaly detection service, so that is a challenging problem because that is something you're trying to make like one side fits everything. So that is where things started become tricky. And also like anomaly detection is like an unsupervised problem. So it does not really come with label data. So that is like one tricky problem to understand, like the performance of the anomaly detector, whether how good it is performing versus like how bad it is performing. And also, like, since Luminaire is a time series anomaly detection tool, it struggles the problem of handling non-stationarity, which is like a never-ending problem for time series data. And also for batch and streaming time series anomaly detection, those are two very different problems. We have observed, like from our past experience, like when you start aggregating the data or like you start seeing the time series data over different frequencies, the behavior of the data changes a lot. So these are the different issues that we have to keep in mind when you're building time series anomaly detection or anomaly detection in general as a service. And from the actionability point of view, that is also like a very important aspect because like anomaly detection comes with an error rate because it's a probabilistic solution. So you have to understand like if your model misses or fails sending an alert, or there is some issue in the model or in the pipeline that alert does not receive to the end user, what is the cost of that? So that is a very important problem to handle. And also like the time sensitivity, because in many cases, mostly in the streaming use cases, detecting anomalies in time is a very important problem.
And so, in terms of the actual design of Luminaire, how are you addressing some of those problems of being able to solve for the general case while also being able to provide some escape hatches or tuning capabilities for being able to identify some of these special cases or make it fit a particular use case, and just managing the flexibility and the breadth of the overall problem space?
Yeah, so Luminaire is an anomaly detection tool which is supposed to work for wide ranges of problem. So we take different measure, and since it's a machine learning, internally it uses machine learning. We take standard techniques followed in the machine learning literature that kind of processes the data, models the data, and then use it for training. So from the beginning, like we start with data cleaning, we check for non-stationarity and do all the adjustment that you need to do for modeling or dealing with the time series data. And then we get signals from the data itself. And as I mentioned before, since we have less control over the externalities, we use the history of the data in order to incorporate all the information we need in order to model for anomaly detection. We check for example, temporal correlations like periodic patterns, or sometimes we have seen in use cases where data has like local non-linearity. Those are the things that are incorporated during the model building process. And finally, like all these steps are like require some actions and some decisions that the users need to make. That is where Luminaire stands out from the other systems, and Luminaire has a built-in configuration optimization feature as well, where the user just comes in and says, okay, like I would like to monitor my time series, and for a given problem we optimize the configuration based on the data set, and that actually brings a lots of automation during the process. This is like one side of the thing, and another side is like how to deal with streaming solutions, because in streaming anomaly detection, or specifically for streaming data that I mentioned, like it behaves differently. We have different solution, like instead of like doing like a predictive or uncertainty based modeling, we do some sort of like baseline matching or density matching, where we do like data checks over sequential windows in order to see like whether has healthy or not. So yeah, these are the typical steps or measures we take to build Luminaire as a successful anomaly detection tool.
And on the subject of the windowing, that can be another challenging optimization problem, is determining what are appropriate sizes for those windows for ensuring that you're actually, determining what is the proper bucket for being able to determine whether something is anomalous, and, how much information do I need for being able to compute that. And then also cases such as seasonality, where something might be anomalous within the previous time window on the order of days or weeks, but on an annual basis, it's actually entirely normal. And I'm curious how you handle some of those types of problems.
For the windowing aspect, this is a very important question, because sometimes like the anomaly detection specifically like this kind of problem are like context based. So sometimes, let's say at the middle of the night, you have less traffic or some data showing very low volume, high variability. So we make sure we consider the seasonalities of this pattern. Like if it is a repeating pattern, then we consider that into incorporating that model into the model. And also in terms of determining the size of the window, we take measures of setting like the either the user can pick the size of the window for if the user knows what would be the optimal size for their problem, or we are actually working on like bringing the automation of measuring the same problem over different window size. That means you're basically seeing the problem over different contexts. We have seen in many use cases like that seems to work pretty well, and does not really implemented inside Luminaire right now, like changing the window size for a given solution, but we are planning to build in future.
And also, like, that is definitely a tough problem. And right now, usually what we have seen is like, usually like if your data in terms of streaming, if they are like in, like you're receiving data, let's say every second or every minute, right now we kind of expect the users, as of what we provide right now, to give us that kind of information. And yeah, that definitely is a challenging, but at least for the batch style of processing, that becomes very much easier. Like if your data is like you are getting your frequency of your data is like every day or every week or every month or even like every hour, that is where it becomes a little bit easier to automate that process.
And in terms of the actual design and implementation of Luminaire, can you dig into some of the internals of the project and some of the ways that the design and goals of the project have evolved since you first began working on it?
Yeah, so it initially started from like just implementing with a basic ARIMA type of model. And we just had the training data, doing some basic cleaning, and we're processing that, doing anomaly detection. And we've seen like there are many caveats and in dealing with like anomaly detection in time series data. Specifically, you have to deal with if you have missing data or you have some change points in the data, which is a very serious problem in time series modeling. So we take different measures of detecting those and making the data ready before it goes to the model building process. Luminaire has three main components, which can be used independently or sequentially in order to perform a complete end-to-end anomaly detection. So that start with like the data preparation and profiling. So in the preparation and profiling part, you can prepare the data for being ready for modeling. And you can also do some exploration where you can see what the historical patterns and what has changed in the data. So processing in the sense like the Luminaire detects change points, and also like Luminaire detects trend turning, which are very useful and like sometimes interesting to see in many use cases. Data imputation if there is missing data, or like doing any other adjustment if there is any change point observed. And in terms of the modeling, we internally in Luminaire, like we have different type of models. Some models focusing on the forecasting capabilities compared to some models focusing on like the variational and uncertainty pattern where the data has very less signal. And on top of all of this, we have an optimizer that can optimize the choices given a problem. So if you have a data, Luminaire optimizer can run different scenarios and check which specific configuration fits best for a given problem, and it can suggest the best optimized configuration to you. And on top of that, like what we do, and also like whoever uses Luminaire, they can run a scheduling engine like for training, like in terms of scheduling the training and the scoring process, because time for specifically for time series modeling, you need a very periodic structure of training and training specifically because you don't want to use a very old model in order to score newer time points. So you have to make sure you're always generating new and most recent models at a specific frequency. And for streaming use cases, it is like a trade off between efficiency versus speed, because in streaming use cases, you want to process the data fast and you want to send the result to the user in a timely fashion. So as I mentioned before, we do like a baseline comparison, like a volume comparison or distribution comparison approach, where we compare different time windows and we take a baseline time window and we do the processing. And similarly, we have a training scoring schedule for that. And the scoring process is very lightweight, where the most recent model can be used to pull the relevant baseline and can be used to score that specific window to see any problem is there or not.
And I'm wondering what the motivation was for releasing the project as open source and any extra effort that was necessary to maybe remove any assumptions about the way that Luminaire was being deployed or used based on how it was being employed at Zillow, and how to make it more general purpose and accessible for people outside of the company.
So we actually looked for several solutions out there, like first when we are trying to solve this problem. And there was no tool we found like that solves the problem the way we want. Because as you mentioned before, actually, the time series model comes with several challenges dealing with the seasonalities or dealing with streaming versus batch data, or like solving the problem of non-stationarity. So that encouraged us to build our own solution. And we wanted to open source Luminaire because like whatever we have built, we wanted to contribute back to the community, because like since we have already invented the wheel, we didn't want the wheel should be reinvented because we are solving a very common problem, because anomaly detection is not a problem within Zillow, but even outside, many people are trying to solve the same problem. And basically, like this is an industry standard as well. Whenever you open source something, instead of different people working on the project independently, rather than building something on top of each other, some on top of your solution, so that we get incremental increase and overall the whole industry benefits from it. And finally, like the open sourcing helps incorporating a lot of brains, and if we want to have like a high quality solution, this is like a good way to go.
Also, one of the problems in the initial time that we found was when we started providing this utility functions to the teams. Initially they had to select what models to run from the suits that we were providing, and within the same model they also had to specify what parameters they also have to set. So this was one of the bigger challenges that we found, for not just like even for the ML teams, but even for the data teams, because we wanted even like any generalized data teams to benefit from all these sophisticated ML systems. So that's where we started making our models, like bringing more models to the suite and making it more sophisticated. And on top of that, also added the layer of auto ML. So where users now don't even have to figure out what models they have to select, that kind of becomes one of the parameter to Luminaire. So I would say like that is like one of the key things that has helped a lot of the teams at Zillow right now and solving a lot of the time series problems, because teams are also not just onboarding just one time series that they are interested in. They are onboarding like hundreds or thousands of metrics that they care about. And imagine the time a team has to spend figuring out for this one metric, what model should I select and what parameters should I set in, and scaling that to thousands of metrics. So that's where we are like trying to solve that bigger problem. And that was the main motivation also to make it open source, because as also Sayan mentioned, like nothing we saw was available to solve that use case.
Python has become the default language for working with data, whether as a data scientist, data engineer, data analyst, or machine learning engineer. Springboard has launched their School of Data to help you get a career in the field through a comprehensive set of programs that are 100% online and tailored to fit your busy schedule. With a network of expert mentors who are available to coach you during weekly one-on-one video calls, a tuition-back guarantee that means you don't pay until you get a job, resume preparation, and interview assistance, there's no reason to wait. Springboard is offering up to 20 scholarships of $500 towards the tuition cost, exclusively to listeners of this show. Go to pythonpodcast.com/springboard today to learn more and give your career a boost to the next level. For individuals or teams who are adopting Luminaire, can you talk through the overall workflow of introducing it to an ecosystem or a particular application, and what's involved in actually getting it set up and training the model and getting it deployed?
So ideally, what this open source package is providing you is the brains, which is the models. Now, for teams, if they want to leverage it, so their main goal is, first of all, the matrix that they care about. And that matrix basically involves, like, let's say, two main columns. One is your time column and one is your actual metric column. So that kind of becomes the initial inputs to Luminaire. And then you train it using that historical data. So make sure you provide enough history so you get a proper model, trained model. And now you have this trained model which is getting outputted. Now you want to store that model somewhere, and that can be any of your desired storage format. You can either go with any kind of file storage, or even you can store the object in a database if you like that. So that was the main reason of like decoupling the model with the storage and everything around it. Once you have this model, now the time becomes is scoring. So let's say if you have the metric which is generated every day or every hour, so you can have your scheduling system that can run at that interval and pulls that trained model to score that specific metric and determine what is the score of that metric. And that's not where the process ends for the user, because scoring will output few metrics about the scored results. From there, you also have to figure out like for your stakeholders, what is the sensitivity that they are interested in. So if it is like highly sensitive, like if it is like highly anomalous, then only you want to get alerted. Or if it is like, say, like 95% anomalous or 99.9% it is anomalous. So like anomaly is different for different users. So that's where users just have to set up what threshold makes more sense to them. And that's how you leverage the output to figure out if this point that we just scored right now is an anomaly or not. So that's how you design your basic training, deploying of your model, and the scoring process.
And are there any particular common patterns that you've seen either internal to Zillow or from users of the open source project as to ways that it's being integrated and some of the sort of main use cases that people have been able to benefit from?
So this system, this model that we provided and the example that I shared was just for one metric, okay? And in a larger system, and even within Zillow as well, we have a lot of teams who wants to leverage this. And they just don't want to leverage it just for one metric, I said. They want to leverage it for multiple of their metrics. So one thing that we have developed like internally, and that what we recommend to the listeners as well, is creating a process where your inputs is not just one metric, but it can be multiple metrics. Let's say, for example, you have some like page views by devices of your website, okay? And you can have multiple devices over there. So you want to create a process where you give that query or that data set as an input, and you want to like divide each of this metric into each single mini process and train and score them, train and store the model object, and then do the same process even for scoring. So that's where we recommend users to create some kind of mapping mechanism. So for example, one of the metric might be a devices is like iOS, and one of your metric is page views. So you can create a mapping for that specific metric and assign some kind of a unique key, and that's how you can scale your system. So that's one of the aspects of scaling. And another thing that we have also seen is the code that is written is pure Python. So if you have a lot of this matrix that you want to run parallelly, so you can leverage some kind of distributed processes. So internally we are using this core pack, like this package with Spark. So that helps us to train all this individual metrics in your data set much more faster and even score them faster. So that is highly recommended to leverage those kind of distributed processing. And another thing that we have seen is if you have a metric or a data set that you are in, like you have generated, but there might not be just one team that is interested in that metric. We have seen a lot of the other product users or business users are interested in that same metric. Let's say, again, take the example of, let's say, page views by some devices. Okay. So there might be a lot of business stakeholders who care about that metric and they want to be notified if there is some kind of anomalies. So instead of like each team doing that same training and scoring process for the same metric, you are kind of duplicating that whole resources. So what we have done is we have just on like created a process where user can come in and say, okay, this is that job which is running, and this is that metric that I'm also interested in, and I would like to get alerted if the sensitivity breaches certain level. So that way what we are doing is we just have one process which does the training and scoring, but we have another process which maps the result of the scored value to the subscribers and notify them accordingly. And we have seen that has helped to a lot of our teams and stakeholders. So definitely something we would recommend. And one last thing is when we initially started Luminaire, and in order to onboard jobs, it was more like a config driven, like people had to specify their query in some kind of config form, which they push it in our repo. And a lot of the non-technical users were finding it difficult. So what we started is we started creating a self-service UI, and we integrated that with our data catalog system. So where like user can easily come and onboard any kind of job process they'd want to do, and also easily specify the alerting thresholds, and we automatically just take care of all the downstream processes, like all the scheduling processes, all the orchestration around it, airflow, running the jobs in PySpark. So decoupling all this process and making it as a self-serve is definitely has benefited Zillow and a lot of teams at Zillow, and something we would recommend all our listeners to also try to do that.
One of the other interesting aspects of things like anomaly detection and working with time series data is situations where you have some protracted anomaly, such as the current situation with the pandemic, where everything is thrown out of whack and things that might have worked well for your steady state are now difficult to predict because of the constantly changing environment. And I'm wondering how that affects the work of people who are using Luminaire or who are trying to identify sources of the outliers in the anomalies that are detected, and just sort of the overall impact of things like the current pandemic on people who are trying to use time series for building meaningful signals that instructs the way that they want to drive their business or manage their data pipelines or things like that.
As I'll repeat what I said before, so anomaly detection is like a very contextual problem. So in the context of the current situation, like in the pandemic, like we are kind of living in an anomalous state right now. But the nice thing about like the time series models or using Luminaire or any other tools is like you can tweak them to bring more contextual information into the models. So, for example, you can work on narrower time windows, which are like cases for many matrix. Like, for example, like many operational matrix, they don't depend on like long-term history, and you can treat them and you can detect any problems in narrower, like on a local history, you can take in and detect any problems into that. But in general, like the business matrix or other matrix which has a longer context of longer history, that kind of get more impacted. So in general, like the time series models are very fast to adapt, and when you want to have anomaly in the context of a local outlier, like you're trying to find like something happened today which is independent of the overall context of these pandemic, and time series models are pretty good at that. But in general, like when you are dealing with such different like data of such a different pattern, it's ideal is to observe it from different perspective and involving like varying time windows and understanding the relationship between different time series, or somehow correlating the time series or correlating the outlier sometimes help, and also like doing some multivariate processing of the time series where you can relate one problem with another one. That helps a lot. So even though you have such big impactful externalities such as COVID or it's like this pandemic, I would say like, yeah, I mean, taking this measure helps a lot.
And in terms of the specific projects that you've seen built with Luminaire, either internally at Zillow or out in the community, what are some of the most interesting or innovative or unexpected ways that you're seeing it used?
So in general, any anomaly detection tools are designed to work as like detecting anomalies in the data. Like even internally, like we have seen use cases where teams are using Luminaire to detect like the different quality matrix related to model. That kind of takes Luminaire just being like a data quality tool rather than from a data quality tool, like a tool that monitors like a whole ML data or a product system. So for example, like we have teams who are using this for tracking model drifts or any changes in the code that might have introduced the bugs, which have changed the outcome of the model radically. So that's where Luminaire comes in, and not only Luminaire, that means tracking the input side of the thing, but also tracking the output side of the thing. And also, like, there are situations where Luminaire has been used as tracking slow drift, where you see like models are going down, model performance is going down for some specific regions, some temporal change, slow temporal change in the data, which cause like slow drift, not a steady jump or drop. So these are like some many interesting cases where we haven't seen anomaly detection tool being used, but Luminaire is being used in these cases.
In terms of the external users, it's been pretty recent that we open sourced the project. So we have not like got much like feedback from the outside world, like how they have been benefited yet. That's where we are like trying to spread the word and see if someone has used it and if they found anything. Yeah, that is something where we are happy to learn more from them as well.
And in terms of your own experience of working on the Luminaire project and using it internally for your own projects, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
There are several aspects of answering this question. Like, first, from a system point of view, like as I discussed before, like one of the challenges of dealing with not only for anomaly detection problems, specifically for time series problems, it has like temporal dependency, like time is itself a factor in it. So it is very important to understand this time factor, not only from a statistical perspective, but also from a system perspective, because that's where we make sure like we are processing the right anomalies and we are sending the optimal number of alerts to the user. So from the system perspective, it is very important to find the sweet spot of scheduling the training process, because you want to train your model frequently, but not too frequently. That will increase cost of resources, and but also like you don't want to train it very infrequently so that it creates like start degrading the model. And also we have a context of model TTL, like time to live, where we publish a model that comes with an expiry. That means like if you have published a model that would expire in some point, that is deliberately done because we don't want to use a very old model to score a recent data point. So these are the different things from the system side of the things you need to understand when you're dealing with time series data. Now, from the alerting side of the things, like from the user's point of view, we have seen challenges in like setting up the post processing, like how do we process the output from Luminaire. So in the context from a user, sometimes we send an alert which user find kind of obvious because the context that model is training is different from the context the user is looking into the model. For example, like you're seeing like continuously a metric to be at the 100 for like last few months, and suddenly you have seen that to be 101, and that time like you will get an alert. But from the user's perspective, user might think, okay, I don't really care about 100 being 101, I want to know like when 100,000. But so these are the different challenges we have seen, like from someone coming from a non-ML background to see this kind of problem in a different angle. And from a probabilistic perspective, like anomaly detection is a probabilistic classification which comes with an error rate. So it's very important to understand as well, like what matrix you want to monitor. As Smith mentioned before, like there are user like who comes up with a task with lots of matrix, and it is very important to understand which are the important matrix to monitor, because if you onboard a very noisy matrix or very unimportant matrix that usually generate noise, it's tend to get more alerts from those matrix rather than from the stable ones which you think to be more important to monitor. So for this reason, we like internally like have smart alerting processes where we do some alert throttling, muting, grouping, so that we make sure like we send the right amount of alert so that it does not really create an alert fatigue, so that the user start ignoring the alert, but also like it does not suppresses an important alert.
I would just like to add one thing over here that we learned from the initial stages was initially we were just sending out alerts for that one point itself. So what was happening is like users were always not having the context of like why is this point treated as an anomaly. So they always wanted to know the previous trend along with it. So that was like one of the interesting and challenging thing. So that's what we started to do is we started showing not just the recent data point that we scored, but we also started showing them like last couple histories of what was observed. So showing that context and showing your anomaly along to the user helped them a lot to immediately make the decision, oh, okay, this is why it is an anomaly. Like sometimes the significant dip or drop might not be obvious, but then it becomes very obvious when you show them the current point and some history with it.
For people who are evaluating Luminaire or trying to understand if anomaly detection is the right tool for their particular problem, what are the cases where Luminaire is the wrong choice?
When I introduced Luminaire, we mentioned like Luminaire is an anomaly detection tool which works for wide ranges of time series data, and it also brings automation. That means we take historical information, patterns, or like different structures in the time series to understand what is an anomaly versus what is not. But if a user has more information about the data, like more information about the externals of the data, or like more context on the data, then building a more feature-based model will make more sense. So in that context, like for example, like if the user knows like there will be like major release which might increase the traffic by much, then incorporating this information would reduce an alert, which is a good thing because the user already know if the alert is coming, why the alert is coming. This is like a very important aspect. Like if you have more information from the data, like then building a feature-based model. And also it's important to understand whether you have the resources to build a feature-based model. If you have the resources and if you have more context of the data, I would say Luminaire, far better option to go beyond Luminaire.
This also kind of ties with the challenging part of it as well. Like sometimes people, if they are alerted, they want to get more context on why something is an anomaly. And that's where like the teams have to later on dig into it. And that is more like outside of the scope of the package right now. But that is something teams should think more about it. Like it's something as an anomaly, trying to give them more context if possible, why we think this is an anomaly, like not just specific to the models or to the characteristics, but is there anything external reasons that might have caused it? And that's one of the very challenging problem.
As you look to the future of the project, what are some of the plans that you have for the near to medium term, or any areas of contribution that you're looking for help from the community?
Mostly we are now like working on the streaming anomaly detection model, and that is at this moment is a very initial stage. We have open source the first version of it, but we would like to build and bring more automation and bring more sophisticated feature into it to bring more end-to-end processing, like where the user would need less configuration. Also, like from the context of where Luminaire is a wrong choice, as Smith mentioned, giving a context of an alert would bring more insight on why someone is getting an alert. So from that perspective, diving and doing some root cause detection, like doing some data driven context extraction is a very important part. And we actually published a paper last year about root cause detection and how we are planning to do that inside Luminaire. So that is one key part. And in terms of improving the existing anomaly detection model, we are planning to incorporate more sophisticated model into the system. And currently we do optimization, but we are planning to do some voting or like some sort of bagging approach in order to identify if something is an anomaly versus non-anomalous, because that like having an ensemble approach of dealing with the classification model would bring more reliability. So that is something we are planning for future.
Are there any other aspects of the Luminaire project or the problem space of anomaly detection and dealing with time series data that we didn't discuss yet that you'd like to cover before we close out the show?
So right now, what we internally kind of do is like having a fixed frequency when the training runs, okay? But that is also not a scalable solution. You actually want to trigger tuning when actually your model is degrading. So you want to tune your model based on your past scoring results and taking that into effect. And if that degrades, then only you retune it. Yeah.
So basically, this is like an internal tool that is not in the open source project right now. So what we do is, so we talked about the automation part, but this is more of a self-awareness part where it reduces the maintenance cost as well. Because when you onboard anomaly detection model and when you want to monitor something, you have to continuously check like whether the model degrades and when you want to retune, because you don't want to retune at every stage as well, because that kind of makes things less reliable and also like increases the computation cost, because like the tuning part is pretty expensive. So what we do is like whenever we score, we store some model performance matrix, and every time when the retraining schedule is there, we check whether the model performance starts degrading with different voting methods. Like we take different measures of measuring a model, and if we see like, okay, this model should be retuned, we trigger a retuning. So that means like it's kind of a complete loop of full automated ML system.
That's very cool. So for anybody who wants to follow along with either of you and get in touch, I'll have you each add your preferred contact information to the show notes. And so with that, I'm going to move us into the picks. And this week, I'm going to choose a tool called Flake Hell, which is a wrapper around the Flake 8 linting utility, which gives you the ability to maintain your configuration in the PyProject.toml, as well as better maintenance of plugins and determining which errors you want to have reported and in which contexts or for particular paths. So just a great convenience utility on top of Flake 8. So definitely recommend checking that out for maintaining code quality. And so with that, I'll pass it to you, Smit. Do you have any picks this week?
Like over like last couple months, I am like looking into this tool called Apache Ranger, which is an open source tool. And it kind of provides you a way to manage or control data authorization. And the reason I find it very interesting is because as the companies are becoming more data driven companies, a lot of data are getting generated every day, like every minute actually. So, and now a lot of teams also need access to this data. So how do you control that? And that's one of the interesting project I found. And that will be the pick of that will be my pick.
And Sayan, do you have any picks this week?
So I would like to pick a book recently I read, that's Prediction Machines, The Simple Economics of Artificial Intelligence. So I found this book interesting because like this talks about from a broader aspects of machine learning and AI and predictive modeling. So specifically those who are working on very technical side of machine learning, like the machine learning practitioners or even the data engineers. This book should be very interesting for them because this gives a broader picture, like from a business and strategy point of view. So I highly recommend to everyone to read this book.
Well, thank you both very much for taking the time today to join me and discuss the work that you've done on the Luminaire project. It's definitely a very interesting tool and one that I plan to take a look at myself. So I appreciate all the time and energy you've put into that, and I hope you enjoy the rest of your day.
Thank you, Tobias, for having us on your show.
Thanks, Tobias, for having us in the show and for all your time. Thank you.
Thank you for listening. Don't forget to check out our other show, the Data Engineering Podcast, at dataengineeringpodcast.com for the latest on modern data management. And visit the site at pythonpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts@podcastinit.com with your story. To help other people find the show, please leave a review on iTunes and tell your friends and coworkers.